Welcome to our Database and Memory Office Hours session. Today we're going to talk about 23C new features, and all of the features I talk about are actually available in 23C free, so 23.3 version, the one that just came out fairly recently. I do have the AskTOM Office Hours landing page up just to again point out, as I like to, that I have some resources here. So if you want to check out the blog, which I may mention, any previous Ask Hours presentations and scripts, I do make scripts, and the presentation that we'll go through today, I create a PDF and I'll put it up there if you want to go to that link. And then obviously you can go look at the video and then documentation in Memory Advisor and our live labs. So we don't have a live labs up for 23C yet, but certainly you can go back and look at how database and memory runs in 21C and below. And we have a whole bunch of labs, original lab, and then a bunch of advanced features that I added in a while back. So we have plenty of resources, and of course our previous Ask Tom sessions as well. So with that, I will shift over my presentation and introduce myself. And if you have questions, please feel free to put them in the Q&A. I will try to pay attention and definitely want to be able to answer any questions you might have, whether it's about new features or even anything else that you have questions about with regards to database and memory. So again, thank you for attending. My name's Andy Rivenis, so I'm a product manager for database and memory. We've been doing these Ask Tom Office Hours sessions for quite a while. So if you want to go back either on the blog or on our other Ask Tom Office Hours sessions and look at some of the features and things we've talked about, please feel free to do that. You can follow me on Twitter, and I try to tweet out announcements and information in the new blog post, or for instance, this Ask Tom session. And if you have questions, feel free to email me. So my email address is right there. And the whole idea is to provide information so you guys can understand how database and memory works and how it might fit in your environment. So with that, let's go ahead and get started. Maybe. There we go. So 23C new features. So as I said, I've done all of the features that we're going to talk about, and they're all available in 23C free, which is the current version is 23.3. So be careful, because we had a previous version that I think was released in the April timeframe, which was 23.2. So the 23.3 version, there will be another version, a GA of 23C, that will have some more features in addition to what we're going to talk about today. But for the most part, these are the core database and memory features that are part of 23C. And even though 23C, I actually should have put in the limitations on the 23C virtual, or the database itself, because you can only have 2 gigabytes of memory. You can have 2 CPUs, excuse me, and up to 12 gigabytes of disk space for the database itself, not in the virtual machine or wherever you choose to run it. But the point is that 23C environment, kind of like the old XE environment, has everything available in it. So you can use all of the Oracle Database Enterprise Edition features, database and memory, and other like advanced compression. There's other information, and I think I have a link here to point you to where you can go get 23C free, or you can just Google it. It's on the bunch of places on the web that we've had announcements of the availability for this. But my point of this was just to point out that you can try all of these things yourself in your own environment if you create a 23C free virtual machine, Docker image, whatever that's available. So you can go ahead and try this yourself. But anyway, so I pretty much tried to make it as large as I could. So I used an SGA target, which will become important as we talk about some of the features, of 1400 meg, and that left 600 megs for PGA and Linux to deal with the Oracle database and all the processes. And then I set initially an in-memory size of 800 megs, and I populated I used the SSB schema from Live Labs that I have from Live Labs, but I only used a couple of the partitions because otherwise it wouldn't all fit. But that's not all that important. You can use any kind of data you want to try this out. So you don't have to do SSB. You can, try your own data, or there's the SH, there's some schemas already in 23C free that you can use to experiment with. And really probably the only caveat is it is a limited environment in the sense that you're not going to see the kind of performance you would in a real environment where you have, hundreds of gigabytes of data and memory and column store and all of that, and multiple CPUs and the rest. So it's just really meant to be an environment that you can play around with and kind of see how the features are going to work and then in a larger environment. So the features I wanted to talk about today for database and memory. So we have made some changes to the $V in-memory area, or the column store itself. And we'll talk a little bit about that. We've got a new feature called selective columns, which is kind of nice because now you don't have to type out all the column names. You can actually say all. So I'll show you a little bit about that. We've made some enhancements to automatic in-memory. So now automatic in-memory can automatically create things like join groups and the performance features, in-memory optimized arithmetic and others. So that's kind of nice. So we're really trying to move database and memory to be, I want to say autonomous, but automatic in its usage or population of objects, and allowing you to get the maximum performance without you having to continually do alter table in memory and figure out what features you should enable. Should I put join groups on? Should I do in-memory optimized arithmetic? There's some other features as well. So we'll do that for you. And so that's kind of pretty exciting, I think. We've been on this, we first introduced automatic in-memory in 18C. And so we've been on the journey to make this as fully autonomous, if you will, for lack of a better word, as possible. And then a new feature, something we're calling automatic in-memory sizing, allows the column store to be part of automatic shared memory management. So now, not only can you, when you set SGA target, the database will manage, the shared pool size and the buffer cache. It'll also manage the size of the column store, so it can automatically grow or shrink based on usage, maybe during different workload periods. So I think that's pretty exciting. We've enhanced in-memory deep vectorization. So we had deep vector hash joins, and so we've added a bunch of additional join types to the support for that. And then there's a new in-memory advisor. I blogged about this and talked about the eligibility tool, which is now native in a package, DBMS in-memory advice. And so there's also an in-memory advisor that goes along with that. And that's also part of the database. So now although you could still use the old in-memory advisor, which you download off of OT or Oracle.com, and actually goes to My Oracle support, you can still use that. But now you can use the in-memory advisor. It's it's heat map aware, and heat map, by the way, as we'll talk about, is no longer licensed. So you can use it without incurring, having to have either advanced compression or database and memory. And since it's part of the database, you don't have to go install the separate utility, which is important for a lot of people because you can't just go changing production and adding packages and doing things without going through a fairly rigorous process of ensuring that there isn't going to be any side effects. And so now we're delivering this as part of Oracle database. So there was a question, are in-memory features available in Oracle Standard Edition? No, they're not. So just like the base level feature we talked about, database and memory is part of Enterprise Edition. And so for on-premises, you have to have Enterprise Edition. It's available in the cloud on the extreme performance version of database OCI. And then it's on all of the EXA flavors, so EXA-CS, the different flavors of Exadata Cloud Service, and then Exadata Cloud Customer, and we did announce that it's available on Autonomous Database Dedicated, and so it's available there as well, but it's not available in Standard Edition. None of the options actually are available on Standard Edition. So sorry about that, but that's just the way that works in Oracle land. So let's continue on. So changes to $V in-memory. So what we've actually added is a new pool. You'll see that we have the 1 meg pool, and this is literally what I used to test with. So as I said, I had 800 megabytes allocated to the in-memory underscore size parameter. So I had a 1 meg pool and 64K pool. That's not different. The 1 meg pool is review is where we store the IMCUs or in-memory compression units or the columnar formatted data. 64K pools where we have the metadata or snapshot metadata units where we keep track of what's happening to each of the IMCUs. And then there's an IM pool metadata, which is actually what we've done is, especially for rack environments, we've taken most of the space that we were using in the shared pool to manage the IMCUs changes and the blocks that make up those IMCUs, the mappings in a rack environment in the shared pool. We've moved those into the column store. So that's a change that you'll see as part of 23C. And the idea being that we've had a best practice where we've said on rack, you should generally allocate about 10% of the space that the column store uses as additional space in the shared pool. And so that recommendation will get changed as we now make use of this third pool in the $V in-memory area. So I just kind of wanted to, that's not so much all that exciting, but I wanted to point that out that as you start playing around, you might see this and kind of wonder, oh, what's going on there? Something's different now. So with that, let's move on to selective in-memory columns. And so what's kind of interesting about this is we've, in order to reduce the amount of space that you need, you can exclude columns from column store. But in the past, you've always had to, you say alter table in memory, and it was always an exclusion. So you had to list all of the columns that you wanted to exclude from population if those columns, say, weren't being used for analytic queries, and you didn't want to use up the space to have those in the column store. Now you can actually say alter table in memory all, and no in memory just the columns if there's a small number of columns. But the even more interesting one is the first one, where you can say, well, if I only need just a very small subset of columns, I can say no in memory all, so I don't want any of the columns, and then I'll just list the specific columns that I want added. So the idea was to make this a little simpler, easier to manage as far as excluding columns and only having specific columns populated in the column store for a given table or partition or subpartition or materialized view for that matter. So that's kind of nice. So that's a nice one for a little easier way to manage the column store. And then I had an example with a test table that I'd created. And as you can see, I said in memory, just 2 columns, and then no in memory, all the rest of them. So I don't have to spell them all out. And as you can see, if you query a view, which we've talked about in the past, but it's called $IM column level, and you can see that the 2 columns I enabled for in memory are in memory, and then all the rest of the columns are no in memory. So you can see how that works. So that was just kind of and that's an easy one to try out on your own in 23C free, and so kind of a nice to have. So let's get into the kind of the meat. What I think is these next 2 features are biggies, in my opinion, for making the column store and database in memory easier to manage. And so the first one is enablement of, so automatic in memory can now, not only can it populate and evict objects based on heat map usage statistics, but based on the usage, we're keeping track under the covers of how those objects are being used. And so now we're able to also enable certain features, go to higher levels of compression. And so I have kind of a setting here where you can go see. I should have a couple, say, because I thought I listed. Yeah, I do right there. So there's a package, DBMS Auto IM, that's been added. So you can turn the feature on or off, but you can set a time window. And then there's actually an activity report you can use to generate. So based on a time interval, you can generate an activity report to see what activities occurred. And then there's another view, DBA AIM performance features, where it will tell you the features that are available and whether they're in use. And I listed those features. That's what I was looking for. Is so in-memory optimized arithmetic, Bloom filter optimization, which is basically the ability for us to cache the hashed values rather than having to recompute the hash every time on the fly. Stored using vector optimization, and then join groups. So vector optimization is also another way to improve SIMD performance, and then the enablement of join groups. So we'll have more information about this in the future, but and I'll talk specifically. We've talked about a couple of the 23C features already. I have a blog post that's coming out on in-memory vectorization and more detail than we'll go through today. And I'll go through each of the features in blog posts and show demonstrations, and we may have some future Ask Tom sessions as well. So don't get too we're not going to get too far into the weeds of how each of these things work, but and these have existed. But now AIM can automatically enable these things, and so you can get better performance without having to do anything, which is kind of the interesting part of that. So automatic in-memory features, and then automatic in-memory sizing, and this is huge. This is the ability for the database to automatically resize the column store. And notice it can shrink now as well as grow. Because we've been able to grow it. You had to do it. You had to say alter system and set the in-memory size larger, but you could never set it smaller unless you recycled the instance. Now with automatic in-memory sizing, the database can do this for you. You do have to enable SGA target, just like you would with automatic shared memory management for say the shared pool or the buffer cache. And then you have to set in-memory automatic level, or AIM, to high. So it has to be the high level. In 19C, we only had low and medium. In 21C and now 23C, we have a high level. And just as a quick review, when you set AIM to be high, it changes all of the objects, all the application level objects. I won't do the system ones, but all the application level objects or non-system sys objects to and auto. The in-memory compression will go to auto, and so they're all available to be used for in-memory. So we automatically just say everything's available. You don't have to go individually alter the object, so that you can if you want to override, but we'll just set everything to be in memory. And then with automatic in-memory sizing and AIM high set, we can then not only will we populate everything, but we'll then, based on the workload, change the size of the column store. I mean, you give it an initial size, but then we'll grow it or shrink it based on what's going on in the database based on heat map statistics. So that's pretty neat. So I have an example that I created, and I was able to get the database to grow, but it's on a cycle of the same kind of cycle that automatic shared memory management uses. And so what I did is I set heat map on, so that's a requirement for this. Set SGA target, as I showed you, 1400 megs, and then I had the in-memory size was 800 megs, and actually I lowered it for this particular one to only 400 megs, and that's what I had in the note. And then in-memory automatic level was high. So then I populated my schema, SSB schema, and you notice here that the line order of the partition, and I'm not sure why this one doesn't list it, but I had 3 partitions that I had used out of the 5 that are in the Live Labs environment, and notice it went out of memory. So then we might expect to see that we're under memory pressure because the column store is now full, and we might expect to see that automatic in-memory sizing would then increase the size of the column store as part of automatic shared memory management. So that's the setup. And so then we see it, there was what I use, I query $BDollar SGA resize ops, and you can see that I just reduced it just to the shared pool, the buffer cache, and in-memory area, just to kind of see what's going on as I looked at it, and could see that what had happened is that notice that originally the in-memory size area was 400 megs, and then it grew to over 500 megs. So it's trying to grow it to make more room. And then the buffer cache was shrunk because all I was doing in this single user system was, running queries against the line order table. And one of the interesting things is to be aware of is that the activity needs to continue. So you can't just, let's see, go back. So if you just query, if you have this environment and you just start querying line order table to get some heat map statistics and then stop, then you'll get the results will be that we'll change it, but we won't continue to change things. It takes activity during the period of time that automatic shared memory management is looking at the data during the interval, because it's a 90-second window that it looks as it iterates through to check to see what the activity was. You need to continue to have activity in order to continue to spur the shared memory management to change the sizing. So just a heads up. But the point is that you can see there in this view that changes are being made. So prior to this, you would not have seen the in-memory area, but you would have seen the buffer cache and the other components, if you will. And so the in-memory area, notice, has been added to this as part of automatic in-memory sizing. So again, I'll probably do some more sessions dedicated just solely to this, but I think it's pretty interesting and something you can start to take a look at in 23C free. So with that, I did spend, since I've done doing a blog post, I spent quite a bit of time on this feature. This is actually quite an interesting feature. We introduced the in-memory deep vectorization framework in 21C, and then at that point supported deep vector joins, but they were based on just equijoins. And so kind of like with our Bloom filters, and I did a blog post, and I think we did an Ask Tom session even, with demoing how to get it to work in the sense that being able to see it. And so you can use SQL Monitor, and I'll show you a little bit of that in following slides. But we've added a whole bunch of other joins. And so multiple join keys, semi and outer joins, fully grouping and group by aggregation, and multiple levels. And so what the kind of multiple levels is kind of neat, because now we can take a row source and join and still leverage SIMD vector operations to do the join. And so previously we got benefits in hash joins with Bloom filters in the sense that we could do the join during the scan operation. And that's really the takeaway here, is even without the ability to use Bloom filters, we're getting benefits under the covers of being able to avoid having to go to the probe table in the PGA. We can do this with SIMD vector processing and do the joins during the scan and get much better performance for other types of joins that we hadn't been able to do prior to 23C. So hopefully that makes sense. Well, I'll show you an example, and maybe that'll help a little bit. So I have a semi-join is what I just picked for this, because I was going through all the different joins as I was writing and doing the research for the blog post. And so this is the execution plan. So notice we get a hash join right semi, and we're looking at the part table and the line order table, and they're in memory. So we're doing a table access in memory full. Notice that I have the 3 partitions for the line order table, similar to what we've got in Live Labs. So that the line order table has been partitioned based on year, so that we can show in Live Labs other features like ADO, but not that that's all that important, but just to point out that that's why you see the partition range all. And then as an aside, when we did join groups, so deep vector the deep vector joins and like join groups are a runtime decision. So that gets made at runtime under the covers, whether it will be used or not. And so with join groups, and if you want to go back and look at the blog, I've got a blog post, and I think we did an Ask Tom session on that as well, that you had to go into SQL Monitor on the hash join or each of the different hash joins. You'd have to look at, click on the binoculars, and it would bring up a little page that showed a bunch of statistics. And in there, and I have a picture of this, it would show deep vector join and have a number to tell you that you did do a deep vector join and how many flags it had, the hash join flags. So in addition to using that, it's all recorded by SQL Monitor. But if you didn't want to have to bring up SQL Monitor, you like to use DBMS XPlan, display the execution statistics. We created a SQL statement that would mine the SQL Monitor XML and display the join group. Well, I did the same thing for the hash joins, and that's what this page is about, is a kind of a lead-in to the next page. And that's the SQL Monitor version of it. So you would see deep vector hash joins and the join flags. So you can do it with SQL Monitor active reports, which I highly recommend. Great way to analyze both execution plans and usage statistics, but also in-memory usage. And we've talked about that in the past. But whoops, did I not include? Oh, I apologize. I thought I included the full page. I guess I didn't. So just you can add this to your DBMS XPlan at the bottom. I'll post, let me write that down. I'll post an example on the GitHub along with the presentation, and it'll be shortly in a blog post with way more detail than you probably want to see. So that's probably why I forgot to put it into a slide here. But the bottom line is this is just, follows the output of the execution plan. You can add another SQL statement, and then it'll go through and produce what you have down here to just only to avoid having to fire up SQL Monitor Active Report if you don't want to. So I apologize for the I should have included the whole thing, what it looked like. But again, I'll have a blog post dedicated to deep vectorization. It's being reviewed right now by the developer to make sure I got everything right, and then we'll get that published, and then I'll put an example up. So take care of that. And then again, SQL Monitor Active Report, you don't have to do any of that. You can just go into Cloud Control or whatever if you're using the Enterprise Manager, the Performance Hub, and just click on an active report if you want and see it right there. And that's even easier. So either way. So then let's talk about In-Memory Advisor. So again, if you have questions, please feel free to ask. I answered the last. There we go. Oh, I did. So we're done. So if you have any other questions, I've got my Q&A open, so I'm trying to pay attention as I talk about these features. So one of the other, and kind of the last one for today, is the In-Memory Advisor. So the In-Memory Advisor has proved to be very popular because since we've in the past asked you to, and one of the advantages of database in memory is we don't put just the whole database in memory because people just don't have that much memory typically to do that. And since we're really focused on analytic workload, typically for most workload or applications, there's only a small number of tables and objects that you really need to have populated in memory to get that analytic benefit, because most data is more historical and you're not typically looking at it. But you still had to run or figure out what objects to populate. That was kind of the Achilles heel, because we don't put everything in, or you could put a whole schema in, but if you're memory constrained, which most customers are, then you could allocate a certain amount of memory and just put the most beneficial objects in the column store. And the In-Memory Advisor helps you figure that out rather than you having to know that based on your workload. So that was the previous version. You downloaded it off of oracle.com. You had to install a package. You ran it against the AWR snapshot range, and you could see what objects it thought you would benefit from if you had populated those in the column store. And now in 23C, we've revised or rewritten the in-memory advisor, kind of in-memory advisor 2.0, if you will, and we've made it part of Oracle database. So there's a new package, DBMS in-memory advice, and it's now embedded in the database, and it uses heat map exclusively. I shouldn't say exclusively. I think it's still looking at some other heuristics under the covers, but basically it's, for the most part, using heat map to identify, and we've done a session on heat map if you want to go back and look at all of what is involved with heat map. And remember, heat map is no longer like you don't have to have a separate license. It's just part of Enterprise Edition. So as a best practice, I always tell people just enable it, because there is a lot of information there about what objects are getting accessed and how they're getting accessed, along with the counts, which is really valuable. So anyways, a long story short, we have two pieces to this now. An eligibility tool, which I've blogged about and has been backported to 19C, if you're not aware of that. So in the 19.20 RU, DBMS in-memory advice package is in the database now, excuse me, but it's only for the eligibility feature. And then in 23C, not only is that there, but also the ability to do the new in-memory advisor. So they're both there in 23C. So pretty easy, pretty straightforward. To run the eligibility tool, it's just PL SQL or SQL Plus. You can set a couple variables, and you call in-memory eligibility and give it a snapshot range. That's the 26 and the 30 for AWR. And then it'll analyze that and come back and say, was there analytic workload? So the idea was that this would be a very quick, low impact way to say, do I even need to further investigate whether there's analytic workload in my database? And if it comes back and says yes, then there you go. In my case, all I did was, analytic workload, so it was 100%. That wouldn't be the typical, and normally you probably see much less than 100%, but depends on your environment. And so that's the eligibility tool. Again, I've written about this for 19C as well, and so that's available in both versions. And then the native in-memory advisor, or in-memory advisor 2.0, if you will. So there's in that package, and you can see there it's DBMS in-memory advice. You basically, rather than using AWR snapshots, you basically just enable to start tracking. And so if you get back a task ID, then you can go back and report on that. Otherwise, you can mine it in a view as well and figure out what task ID you had. But this is the example. So anyways, in this case, it was the first try, so the first task ID, and then do a bunch of analytic work. And then you say stop tracking. So that's how you define the period of time you want to analyze for your in-memory workload, if you will, or analytic workload, to see whether in-memory would be helpful for you. And then there's another call, generate advice. So there's a couple of steps here. So we start tracking, let your workload run, stop the tracking, and then generate the advice, which will then populate a view here called DBA in-memory advisor recommendations. And then it's based on task ID, so you can have multiple iterations of looking at different types of workload. And then you can print out the information. So there's more than just these columns. There's a couple other time-based columns in here, but from a simplicity standpoint, what it does is it'll give you, based on the in-memory size, and notice it starts off with 0, so it says that workload is estimated to take 10 minutes with no in-memory, and then with in-memory, based on 300 meg SGA, in-memory column store, 500 and 700 megs. These are how much time reduction we think we'll get, and the objects that these were based on. And so based on that, you can then go and enable these objects to be populated in the column store and hopefully get, if you allocate enough memory, basically a 3x performance improvement in this particular example. The one caveat with this is that it's different than the original in-memory visor, and then it's not going to create a bunch of all the alter table statements for you. So you're going to have to do that on your own. But you can mine, obviously, the view if you wanted to, and using regular expressions and pull out the table, owner and table, and do that with a script. But since it's the way it's set up, it doesn't, and that may be something we'll do later. But for now, it doesn't give you the alter table statement. So one of my colleagues asked about that, and yeah, so it doesn't do that. But that's the advantage here, is that it should be more accurate than the first version of the in-memory visor, because it's actually looking at heat map statistics as opposed to trying to create heuristics on what workloads activity is actually going on. So it should be more accurate, and it's already embedded in the database, so there's no need to install something separate, which can be a huge advantage for folks in production environments wanting to take a look at this to determine what objects might make sense that they've missed out on, without having to install a package and go through the QA to do that. Of course, the other option would be to go back to what I talked about at the very beginning, enable automatic in-memory level high, and then in-memory sizing, and just let the database take care of it. But sometimes there are objects that you want to have, in essence, permanently enabled, or maybe even permanently disabled, and so you still may wind up doing some specific alter table commands in addition. But this is a pretty good first start, and we think it'll be a much easier and simpler way for folks to make use or justify the use of database and memory, because they'll know what objects they're going to populate, how much space they'll take, because you can use them in the compression advisor, and trying to make this a little simpler for you to use. So anyways, that's pretty much what I had today. I don't see any additional questions. You can always get more information on our blog resources page in our blog. So the blog is blogs.oracle.com/memory, and then off of that I have the URL here, the resources page, and so on there links to excuse me, lots of our technical briefs on database and memory, how they work with some of the Oracle applications, our Ask Tom YouTube channel, live labs, all sorts of links there. Our GitHub, where I'll post the slides for this, and I'll make that example available. And then, of course, if you pay attention to the blog, then I don't think there's an RSS feed still with the blog, with the Oracle blogs, but I'll be shortly, and I'll tweet about it shortly, putting out a new blog on in-memory vectorization with more details, and then there'll be more blogs to come after that. So that's about all I have for today. If you have any questions, please feel free to type them in. I'll hang around for a couple of minutes. Remember, 23C free, you can download now. You just go to Google and search on it, or go to oracle.com. So you can try out everything I've talked about today is available in 23C free. So if you want to play around with it, we certainly can go as well back to our 21C version of Oracle Database with a lot of these features, and the AIM demo with AIM High is available in that, and our Live Labs environments. So you can certainly go take a look at that. We have JSON support, all the things that we've talked about that we've added. In 23C, we'll have all of 21C, so text and spatial, all sorts of features that we added in 21C are combined with the new 23C features, and they'll all be available, and they're there in 23C free, so you can certainly feel free to try it out. And I don't see any other questions, so hopefully this was a good kind of overview of what's coming. And again, I will have more details and do more posts and probably more Ask Tom sessions showing some demos of this in maybe a larger environment. so we can see some of the benefits a little bit easier. But it's something you can get started with today until 23C is released as general availability, which hopefully will be shortly, but it'll be sometime in the near future. And so with that, I will go ahead and thank you all for attending. And I will post the video to this if you want to share that as well. And we'll see you next time. Thank you very much.